In this section, we will look at several local and regional wind systems that are produced by locally generated pressure systems. Examples are the land-sea breeze, the mountain-valley breeze, Katabatic winds or other fall winds, and the monsoon system. Land breezes and sea breezes occur on most coastlines. The cause for this local wind system is different surface heating of land and water on a diurnal scale. A thermal low always develops over the warmest region. During the day, land heats faster and becomes warmer than water. Air over land is less dense, rises, and triggers onshore flow, which is called sea breeze. This illustration helps you understand what is happening. The land experiences stronger heating than the water during the day, therefore developing a low pressure system, resulting in air flowing from the sea towards the land. During the night, land cools down faster than water. The air over the water is warmer, rises, and triggers offshore flow, which is called land breeze. The cause for mountain-valley breezes are diurnal variations of surface heating in mountainous areas. Again, a thermal low develops over the warmest region. Sun-facing mountain slopes heat more intensely than shaded valley areas during the day. Mountain slopes develop a thermal low. A valley breeze develops as air from the valley moves upslope. Mountain air cools down faster during the night due to increased emission of long-wave terrestrial radiation. Cooler air subsides downslope into the valley and forms the mountain breeze. Katabatic winds are gravity drainage winds. These are winds that blow down a topographic incline, a hill, a mountain, or a glacier. They are somewhat similar to mountain breezes, but stronger and on a larger regional scale. Large air masses cool over large elevated plateaus, increase in density, and flow downslope. The occurrence of katabatic winds is well known at coastal Antarctica or Greenland, where air is cooled over extended ice sheets. Katabatic winds often get local names in the region where they occur. For example, a katabatic wind in southern France is called Mistral. A Mistral is a strong, sometimes gale force wind flowing into the Gulf of Lyon and the Mediterranean. Cold air is generated over the Alps and the Massif Central and funneled through the Garonne and Rhone valleys. If the same wind system occurs in the Adriatic or Aegean Sea in the Mediterranean, it's called Bora or Bura, a northern or northeastern katabatic wind. Foehn, Chinook, and Santa Ana winds are hot winds flowing down the lee side of mountain ranges. The air warms because of compression and can bring sudden temperature changes to the affected region. The hot fall winds in the Alps in Europe are called Foehn. It's also a general expression for that type of wind. The hot fall winds on the eastern side of the Rocky Mountains are called Chinook, and the hot fall winds on the western slopes of the Rocky Mountains in California are called Santa Ana winds. They are often responsible for the rapid spread of wildfires. A monsoon is a wind system which experiences a seasonal reversal of direction due to seasonal thermal differences between land masses and large water bodies. Monsoon does not mean rainy season. Monsoon regions often experience a wet and a dry season. Monsoon refers to the annual cycle of returning precipitation. In winter, winds blow predominantly off the continents, causing the dry winter monsoon. In summer, moisture-laden air is transported from the sea towards the land, causing the rainy summer monsoon. A region which is very strongly affected by the monsoon is Southeast Asia. The animation shows the rainfall over India from spring to fall. April, May, June, July, August, September, October. No rain in winter, heavy rain in summer, a typical monsoon climate. Here is the explanation. In winter, the Asian landmass has cooled down and is dominated by an intense high-pressure system. The ITCZ is located far south in the central area of the Indian Ocean. The results are cold, dry winds that blow downslope from the Asian interior. In summer, the subsolar point is located in the northern hemisphere. The intertropical convergence zone has shifted northward over southern Asia. Temperatures increase over the large Asian land masses and cause thermal low pressure. The Indian Ocean is under the influence of the subtropical high-pressure systems. Hot, dry air sweeps over the warm Indian Ocean and accumulates a lot of moisture on its way towards Asia. Air is lifted over the warm land and by the Himalaya mountains and produces abundant rainfall. This is a typical precipitation chart for a monsoon climate, showing little precipitation in winter and heavy precipitation in summer. The North American monsoon refers to a relatively small seasonal wind shift over the southwestern United States and northwestern Mexico. It causes dry spring and relatively wet summer weather. Intense summertime surface heating over the low deserts creates the low pressure center over Arizona. Moist air arrives from the Gulf of California and the Gulf of Mexico. It converges and causes heavy precipitation in the afternoons.